Hey everyone, welcome to my channel. Today we will write front-end system design for Uber or just a taxi service. And we will start our design from functional requirements. The first requirement is map view. The app fetches and shows taxis in particular area, and we get details of particular taxi. So let's write that app fetches and shows our taxis or ours. Very similar to what you see right now. Map, taxi, and address, everything what you need from the map. The next one is request a ride. If you want a ride, you tap a button. The app then asks drivers if they want to pick up you. You wait for a driver to say yes or no. The next one is driver response. Drivers get a message asking if they want to give you a ride. They and say yes or no. If they say yes, you get a ride. If they say no, you wait for another driver. So let's write drivers should be able to accept or deny the ride. Before the trip starts, you choose how to pay. You can use Cash, Card, Apple Pay, etc. The choice is yours. So the next requirement is manage payments. And let's write that at the start of the trip, users can choose Cash, Card, Apple Pay, etc. After driver says yes, you see details about the driver. This includes their name, photo, and R type. We'll skip name and photo of the driver for now, but you also see how long it will take for them to reach you. So we will have some estimated time. So let's add when a driver accepts, show driver details to user, and we are focused on expected time for now. The next requirement will be driver-user communication. If you need to talk to the driver, you can send them a message or all them through the app, and opposite, the driver can talk to you as well. So let's add driver-user communication and write users and chat or call the driver if needed. Write in progress our next requirement. While you are in the car, the app shows you where you are on the map. You can also see the route to your final destination and expected time. So let's write the map shows real-time, our location, and route. History in profiles. In the part of the app, you can see your past rides. You can also change settings like your name, payment method, etc. So let's add the user and view, past trips, change settings, etc. So let's move change settings to the appropriate item and cancel the trip, our next requirement. When you reach your stop, you tap a button to add the ride. If you want to cancel the ride before it ends, you can do that too. The next requirement is support chat. If you have problems or questions, you can talk to customer service in the app. The next one, favorites. You can save places you go often. And scheduling rides. If you know you will need a ride later, you can schedule it up to 24 hours before. This makes sure you have a car when you need one. So let's write scheduling rides in advance, and that's all our functional requirements. The next one will be non-functional requirements. Non-functional requirements are about how well the system works, not what it does. So let's add title non-functional requirements. And as you can see, I created some templates for titles, list, etc. just to speed up the process. So let's add our template for the list and change example to the performance. Performance will be our first non-functional requirement. So the map on the app should load very fast. If a car moves or a new car comes into view, the map should be updated very fast. This makes the app enjoyable to use. Mobile responsiveness, our next requirement. The app should look good and work well on different font sizes. Buttons should be easy to tap and text should be easy to read. The next one is error handling and user feedback. If something goes wrong, the app should tell you. For example, if the internet connection is lost, a message should appear to inform you. The app should be easy for everyone to use, including people with disabilities. So the next one is accessibility. And the last for non-functional requirements is multi-language support. The app should work in different languages. This is important if people who speak different languages want to use it. Our next topic is assumptions. Assumptions are things we accept as true or certain without direct evidence. In projects or planning, assumptions are conditions or facts that we believe will happen or are already in place. Let's add our template for the list and add our first assumption. Our first assumption is that user is already logged into the system. This means that this login functionality is already implemented. The next one is Bootstrap tour. We suppose that it's already implemented. Bootstrap tour refers to a guided tour or introduction that shows people how to use the website or app. Integration with existing map service provider like Google Maps or Mapbox is our next assumption. The app doesn't create its own maps. Instead, it uses maps from another service, such as Google Maps or Mapbox. So in this design, we don't think about implementation our map. The next assumption is using set directions from Google Maps to show a path. When someone wants to go from one place to another, the website or app will show route on the map. This route tells the user how to get to their destination. The set directions function from Google Maps helps to do this. And the last assumption is setting language in the header. So if a line sends a sub-language in the header of the request, the server understands that the response should be in some language, for example, in English, if available. The next step is to add simple UI. So let's add a new title and image from the templates. As you can see, I already added the map as image, so we don't need to create it from the scratch. Let's move the image under the title, and here we have a .c. Let's add arrow and subtitle for it. Instead of one, there can be a lot of different texts, so I just added only one for the video. Let's add subtitles. First, here we have taxis location, and below we have our location or user locations. So for now we have only two UI elements on the map: taxis and user's location. Let's on it maybe titles and UI elements by arrows for the location, for the R location, and another one for user location. The next subtitle will be zoom level. So in some mapping libraries or tools, the way the map renders or the data it fetches might depend on the zoom level. Certain features or map layers might only be visible at specific zoom level. And the last subtitle is bounding box. Bounding box defines a rectangle on a map with top left and bottom right coordinates. We will use it to fetch only necessary data. In the next topic we will talk about API. We will have three columns: for REST, server-side events, and WebSockets. REST we will use for request and response, and that's all. Server-side events, it's one-way communication channel from the server to the client. And WebSockets, it's full duplex communication, meaning both client and server can send messages at the same time. We will start from server-side events, and our first endpoint is real-time movement of hours. So let's add title, and endpoint will be server-side events/hours. So in this endpoint, the application fetches the current positions of hours specified with latitude and longitude, and additionally to it, zoom level. So let's add this data to our interface. Interface I request related to data which we need to send. So we will have zoom level, which will be number, bounding box with top left latitude and longitude, and the same but for the bottom right. So bounding box is the area with the map. In the request we add top left position and bottom right position. In the response we receive array of objects, where every object represents a taxi. We have ID of the taxi, coordinates, and type. Type can be economy, comfort, luxury, etc. If we want to show a driver info, we can add driver ID as well. But for now, we just show cars. And our first endpoint is ready. Let's copy it and create another one. Status before setting write, our new endpoint. This API provides updates on the status of a write request before it gets accepted by a driver. So the title will be status before setting write. Endpoint will be server-side events, request updates, write ID. Write ID will receive when a write request is initially made by the user. We'll do it later. Let's delete our interface for request because we will need only write ID. So let's describe only response interface. There are three fields. Status. This field indicates the current status of the write request. It will be accepted, declined, or other possible statuses that the system might have. Driver ID. This is unique string identifier for the driver who might accept the write. And estimated time represents the date and time by which the driver is expected to reach the pickup location if the write is accepted. And the last server-side event will be real-time location tracking during the write. This API is designed to provide continuous updates about the car's location during ongoing write. So let's change the title, and endpoint will be server-side event, car tracking, and write ID. We'll have four fields in our response. The first one, current latitude, represents the current latitude of the car. The next one is arid longitude, represents the arid longitude of the car. Along with arid latitude, it provides a complete coordinate for the car's position. The next field is zoom level. This number indicates the appropriate zoom level for map visualization. And bounding box refers to the bounding box coordinates that encapsulate the car's current location on the map. All server-side events are ready. Now let's add our WebSocket. We will have only one WebSocket. This WebSocket endpoint allows for real-time communication between the driver and the user for a specific write. So let's add our driver-user communication title, and endpoint will be WebSockets, user chat, and write ID. We will not have any request interfaces, so we will have only interface for our response. In the response, we will receive messages. This is an array of message objects that represent the chat messages exchanged between the driver and the user. We will have ID of the message, we will have timestamp and message, the actual text content of the message. Now it's time to implement our REST API request. The first endpoint will be requesting a write. It will be post request, and endpoint will be API/write/request. So let's change our title, requesting a write, and the next one is to change our endpoint. This endpoint allows user to request a write by providing the necessary details, and in the response we'll receive write ID, which we already used in our WebSocket and server-side events. Let's start from our request. We'll have some fields like pickup location represents the starting point of the write. So inside pickup location we will have latitude and longitude. And the same for our destination. We'll have pickup location as a start point and destination as a final one. The next field is R type. The type of R the user prefers for the write. It can be economy, luxury, comfort, etc. And the last field, payment type. This specifies the method the user intends to use for payment, Apple Pay, Cash, etc. So let's copy our template and rename it from the request write to cancel write. It will be delete endpoint, it will be API/writes/cancel and write ID. So let's change our post to delete and change our writes cancel instead of request, and we need to pass write ID. This endpoint lets the user cancel a previously requested write using write ID. We'll not have interface for our request, but we'll have interface for the response. There are two fields. The first one status, current status of the write, can be complete and cancel, or any other. And the last one message, a text message giving details or feedback regarding the cancellation. So let's add our message field. It will be just string, and it will be enough for our cancel write endpoint. Let's add a new one. complete a write. It will be almost the same endpoint as cancel a write. We just need to change cancel to complete and it'll be enough. We'll have here two interfaces, so let's maybe copy the first one and create for response and request. Let's delete previous fields. In the response we will have amount, the total amount paid for the write, currency type, the type of currency in which the amount is donated, euro, dollars, etc. And message. Message can be providing some details or feedback about the completion of the write. The response will be the same, some status that it's completed and some message. Let's save our result and add new endpoint. The next one is fetching past trips. So let's change our title and endpoint will be get API writes user ID. But to be honest, user ID can be optional because on the backend side we need to have some validation in case if we provide incorrect user ID or ID of another user. So this endpoint provides a list of all the past writes taken by a specific user. Trips, an array of trip objects with details about each trip. ID will be ID for the trip, date, when the trip took place, from and to starting and ending points of the trip, price, the cost of the trip, and status. Current status of the trip can be complete, cancel, etc. That's all data which we need to show the past trips. In the price we will show the amount and the currency, so it will be just string, the same as for from and to fields. The next endpoint will be save or get favorites. This endpoint allows a user to save or retrieve favorite locations. Endpoint will be API favorites user ID. So let's change it to post and get. But by the way, user ID can be optional. It will be the same as on previous our interface. Let's change our previous interface, just add array because we will have array of objects. And now let's update the response for our save and get favorites. Let's delete trips here and we'll have name, label for the saved locations can be home, work, etc. and latitude and longitude. I will have only one interface, but keep in mind that for the get it will be response, but for the post it can be request. And the last endpoint is scheduling. This endpoint permits a user to schedule a write for a future time. Let's change our title to scheduling and here we'll have just post API/writes/schedule. And here we can just delete user ID and add schedule. In the interface, we stands from iRequestWrite and we will just add one field, time, specifies when the user wants the write. iRequestWrite interface is the interface from our first endpoint. And here we just delete the old data and add our time, which will be string. That's all our endpoints and API part is ready. As you can see, we added a lot of API requests and we already did good job. Next we'll create dependency graph that visualize the relationships and interactions in ride-sharing system. So let's add a new title and rename it to dependency graph. So let's write it, and the center of the whole system will be map. So let's add new box with title map. The user uses the map to set the location and destination. The driver uses the map to navigate to the pickup and destination points. And as you understood, we will have three items under the map: user, driver, and ride. User can set a destination on the map where they wish to go. Driver has the option to accept or decline a ride request from the user. Ride begins with setting a pickup point where the driver alerts the user. Now, when we have main entities, let's change the color of them just for better visualization. So let's change the background for driver and for ride. As I said previously, users use the map to set their location and destination. So let's add new box with set destination title. So let's change user to set destination and add a new one. Okay, let's add it from the storage. And here we will have right request. So user can go from the pickup location to final destination. The next item in our graph will be accept and decline request block. So let's add new box under the driver and write accept and decline. I think that we can add the decline request block to the user as well as we have in our driver. So we expected that if we accepted the request, we'll have a write. So let's add here accept and decline request. And I guess that we just need to delete end, and now it looks better. So let's proceed with our driver, add a new box, and in the new box we will have chat and all functionality. So our driver and chat are all with the user. And I think that we can add just arrows to the user entity that user can have chat and all as well as driver. So let's just find appropriate arrow. Let it be this big one. Let's delete the small one. And yeah, doesn't look very well, but yeah, it just relationship between user and driver. Next, we will add 3 boxes for the right entity. The first one is pickup point or location, because every write begins with setting a pickup point where the driver alerts the user. So the first box will be pickup location. Some extra information, just let's delete it and write pickup location one more time. So let's write it, and under the pickup point we'll have destination or final point. It's where the user wishes to go. So let's write destination point and the final at the end. The write can be in 2 states, ongoing or completed. Of course we can add more boxes here, but this one are the main entities for our design. Next we will talk about performance, how to optimize our application. So let's add new title here and rename it to the performance. Let's add our template for the list, and first optimization will be auto splitting and minification. I guess every application has it, so let's maybe talk about something specific in our design. For example, optimization of map tiles. By using vector tiles instead of traditional raster tiles, you can achieve better zooming and better performance. Vector tiles are smaller in size and allow for more customization in terms of styling. The next optimization is use agent, for example for map tiles from the start to final destination. So we store map tiles that the user has already visited. When the user revisits these areas on the map, tiles are loaded from the cache instead of fetching them again. The next optimization is adjusting map quality. When user has bad connection, the system fetches lower resolution map tiles. These tiles are faster to load and offer better experience, even if the image quality is reduced. So let's just write adjust map quality. When we have bad connection, we fetch lower resolution tiles. The next optimization is reducing features when we have a low network. In areas of poor connection, reducing the number of features or data points displayed on the map and boost performance. The next one is prefetching. This strategy involves loading map data and anticipation of where the user might navigate next. When the network connection is good, map tiles from the user's start point to their final destination are preloaded, leading to better transitions and less waiting time. The next one is ions clustering. As a user zooms out and the density of ions on the map increases, ions are grouped into clusters. This reduces visual clutter and improves rendering performance. And the last one, use progressive web application. It allows users to install web application on their devices, offering an app-like experience. Each can be offline, load fast, and utilize agent. Now it's time to talk about another topic. As you can see, we did a lot of work, but let's discuss about accessibility. So let's add new title here and add accessibility. I will use short version of it. Now let's add our template for the list. And the first requirement is reader compatibility. It ensures that all elements in our app can be read by reader. We need to use semantic markup and provide descriptive labels for all buttons, links, and form inputs. The next one is contrast. Make sure there is enough contrast between text and its background. This is important for visually impaired users and those who struggle with color differentiation. And additionally to it, make sure to implement dark, light, and contrast them. The next one is touchable area. Increase the touchable area of buttons and interactive elements. Voice commands is our next requirement. It allows users to navigate the app using voice commands, thus and help users with mobility issues. The next one is font size adjustability. It allows users to adjust the font size according to their preferences. Let's add font size adjustability and let's fix one mistake here. Avoid elements that flash or blink rapidly as it trigger some issues in user with photosensitive epilepsy. It's our new requirement. So let's add our requirement. And the next one, providing feedback. If user performs action, provide clear feedback like vibration or sound to confirm the action. Multiple ways to navigate. Allow user to navigate by swiping using buttons, voice commands, or keyboard navigation. I want to add more requirements, so let's increase our box and add easy to use forms. Ensure forms have clear labels and errors are distributed in a way that's easy to understand and read. And the last one, magnification. Ensure the app interface and its elements don't break or become unusable when a user employs the device's magnification features. And for accessibility, it will be enough, I think. So we add a lot of different topics, as you can see, and did great job. But it's not finished yet. So let's add 3 more topics. And our new topic is error handling. So let's change our title to error handling, and it will be similar to dependency graph. I will create some boxes here and describe what exactly we are going to validate. And validation errors. It's our first box. These are issues related to input validation. For instance, when user tries to sign up with an email that's already in use, or inputs a password that doesn't meet the minimum length requirement. The next one, network errors. This involves problems in network communication. It can be caused due to poor internet connection or issues when server is unreachable. The next one is server errors. These are errors that happen on the server side, typically when processing a request. They can be due to unexpected conditions, issues with databases, or even bugs in the server's code. The last one is client errors. These are errors that happen on the user devices or browser, such as issues with local storage or incompatibility with particular browser version. Let's connect our boxes with our title just for better visualization and move forward. And everything what I want to add at this section is 2 more boxes. One is user feedback and another one is developer feedback. So let's add some figure from our templates and add 1 more box under it. And it will be user feedback. User feedback refers to messages or prompts displayed on the end users, informing them about the error and possibly guiding them on how to resolve it. Developer feedback. This is more technical feedback. Usually it's some logs behind the scenes that helps the developer fix issues. This could be in the form of error logs or the state traces. And our new title will be push notifications. So I guess that every mobile application has push notifications. Let's add a list when we write when exactly we want to push notifications. And the first example will be when write status updates. This can include updates such as the driver being on the way, arriving at the pickup location, or any changes in the route. And the next one, chat messages. Chat messages notification ensures no messages goes unnoticed. Write completion. Once the destination is reached, a notification confirms the ride's end. And driver updates. Users get updates about their driver, like changes in the estimated time of arrival or if a different driver has been assigned. Let's add two more boxes for user app and driver app. So let's add two titles. And here I want to write prompt user for permissions. It means that while we don't have any permissions, we can't show anything. So let's write here prompt user for permissions. Additionally, batch notifications. It serves as visual indicators on the app icon, showing things like unread chat messages or write updates. So let's here write batch notifications and change our styles. Let's make it dark as the rest of titles, and here we will have some number. The number 1 in the design shows that there is one unread notification. And the last topic for today is security. So let's add our new title here, security, and add our list from the templates. And our first requirement is sanitize input. Always validate and sanitize user inputs to ensure malicious code isn't being injected into our system. The next one is using HTTPS. Always use HTTPS instead of HTTP for your website to encrypt data in transit. This protects data from being encrypted or altered by attackers. The next one is to minimize the use of third-party libraries or plugins. Every third-party library or plugin can be a potential vulnerability. Ensure you only use well-maintained libraries and keep them updated. The next one, CSP, Content Security Policy, implemented to prevent cross-site scripting attacks. It restricts the source of executable scripts, ensure only safe content is delivered to users. The next one is use ORS headers to specify who can access resources on your site. It helps in preventing unauthorized websites from making requests to your application. Next, avoid inline scripting. Refrain from using inline scripts. They are often considered unsafe and can easily be exploited if there is any form of unsanitized input. Implement proper session management. Ensure that user sessions expire after inactivity and that users are expired to log in again and receive new access. The next one is to implement anti-CSRF tokens in your forms to prevent cross-site request forgery attacks where malicious websites trick users into performing actions they didn't intend. Next, handle GWT tokens carefully. If using JSON Web Tokens for authentication, never store them in local storage. Consider using HTTP-only cookies. And the last one is fraud detection. It's a process used to find dishonest actions. For example, using fake information to gain benefits or money they shouldn't have. That's all for today's video. I hope you found this video helpful. If you liked the video, don't forget to subscribe to the channel. Bye.